I'll just go ahead and warn you up front that this will be a lame joke, like most science jokes, but stay with me anyway. Please. Okay, here we go. Do you ever wonder where the chemists have their lunch? They have it on a periodic table. We've spilled some information about periods of the periodic table. Now let's move on to groups. Groups are the vertical columns in the periodic table. Much like in periods, elements in the same group will have similar properties and are given numbers that indicate the number of electrons in the outermost shell, or valence electron, of that element's atoms. This means that all atoms within a specific group will have the same amount of electrons on their outer shell. For example, all of the elements in group 1 will have 1 electron in the outermost shell of their atoms, while all elements in group 2 will have 2 electrons in their outermost shell. This information is incredibly useful for classifying elements into their appropriate groups based on the number of valence electrons. The classification from the left column, or group 1, to right, group 18, also informs us about each group's specific properties and their names. Group 1 are called alkali metals, and group 2 alkaline earth metals. They are called alkali because they create an alkali solution when reacting with water. Alkali metals are shiny, soft, and more reactive than the elements in group 2. Both groups reside in the 2 leftmost columns of the periodic table. Now, let's explore the middle blocks, which are known as the transition metals. The precise boundary between the main groups and transition metals remains a topic of debate, but they generally span from group 3 to group 12. The term transition refers to the transitional nature of properties between typical metals and nonmetals. The elements in this block, excluding group 11 and 12, exhibit excellent conductivity, have high melting and boiling points, and are hard, strong, and malleable just like metals. However, it also has the ability to form colored compounds, such as in precious stones, and some are immune to corrosion, such as gold from group 11. They offer a fascinating subject of study due to their various behaviors and applications. Our next group is halogens, specifically group 17. Halogens are recognized by taking part in displacement reactions and the salt formation when they react with alkali metals. For example, kitchen salt. The halogens are among the most chemically reactive elements in the periodic table, in contrast to our next and last group, the noble gases. The noble gases, also named as group 18 or 0, are the most stable group in the periodic table. All other elements react to attain the stability exhibited by the noble gases. These noble elements are incredibly unreactive and can even be used to prevent reactions from occurring. Now, I'm sure you have a better understanding of what groups in the periodic table are and the properties they convey. But there's more to explore in our next episode, so be sure to subscribe. Thank you for your continuous support, especially our valued patrons and members who have been encouraging us to keep producing more quality content.